Hello everyone, my name is Ali Fahmi Biazhar. I'm from Group 3-35 and our project title is Cascade Control of Aeration Process in Municipal Wastewater Treatment Plants. My team member consists of Michelle Law Xiao Yu, Lo Jia Cheng, Mas Diana binti Muhammad Khalid, myself Ali Fahmi Biazhar and Siti Aisyah binti Muhammad Azizi. Now I'll move forward to the introduction part. In the wastewater treatment plant, aeration is a very crucial part in the secondary treatment process of activated sludge treatment. It provides enough dissolved oxygen into the wastewater for the anaerobic microorganism to carry out the biological oxygen demand removal, and also the notification in aeration basin of activated sludge plants. Therefore, the concentration of dissolved oxygen is very important parameter to control the activity of microorganisms. In fact, DO concentration can strongly affect the growth of the nitrifier. In wastewater treatment, when the concentration of dissolved oxygen is excessively low, it will affect the activity of microorganisms because the environment has become anaerobic. The microorganisms are not able to react with sludge. This requires the plant to conduct high-cost and time-consuming biomass replacement process, which is not economic friendly. On the other hand, when the concentration of dissolved oxygen is higher than the optimum range, the energy consumption will become high because the aeration equipment need to carry out unnecessary usage. An unwanted microorganism reaction will be promoted. Hence, it is important to implement a control strategy to regulate the DO concentration in an optimum level. There are several approaches to categorize the control structures of aeration control, but only the dissolved oxygen cascade control will be highlighted in this presentation. Now, we move to the second part.
Hi, I'm Mas Diana. I will explain on the problem statement and the objective of this project. According to the Statistics Department, 2.97 billion cubic meter of wastewater was generated by the community and industrial sector in a year. The wastewater must be properly treated before it is being released back to the environment in order to reduce the water pollution. The wastewater treatment can be divided into three stages, which are primary, secondary, and tertiary treatment. The secondary treatment utilizes the biological treatment to remove organic and suspended solid. In this process, the concentration of dissolved oxygen injected in the aeration tank is one of the critical parameters that must be controlled. A control system must be implemented to ensure the concentration of dissolved oxygen is at the optimum level. The objective of this project is to determine an effective control system to control the concentration of dissolved oxygen. Next is to study the important element in the control system of dissolved oxygen and justify the implementation in terms of engineering element. Last but not least is to study the challenges of the control system and observe recommendations that can be made to improve the system.
Hi, my name is Michelle and I'm going to present about the process control strategy. So this is the plant layout of the benchmark stimulation model, and it is the standard stimulation platform that models the water and sludge line of the municipal wastewater treatment plant that performs the biological nitrogen removal using the activated sludge. The biological treatment was involved the primary clarifier and also the activated sludge reactor, and the thickening of the extra activated sludge is carried out along the sludge line where the anaerobic digester is used to stabilize the thickened sludge from the primary clarifier and also the dewatering unit. A portion of the liquid from the thickening unit and the dewatering unit will be recycled back to the primary clarifier. This is the overview of the dissolved oxygen cascade control, and the dissolved oxygen cascade control is aimed to distribute the air based on the oxygen demand along the length of the bioreactor and to avoid high air flow rates at the beginning of the basin. The innermost controller is the simple feedback controller set out in the cascade because the aeration is a non-linear process with increasing response time. The air flow rate is an intermediately variable that is controlled by the inner loop, which is also known as slave, while the dissolved oxygen concentration is the control variable at the outer loop, which acts as a master. The advantage of a cascade control system is that the nonlinear dynamic of the element in the slave control loop can be compensated by the slave controller, meaning the master controller can see a more ideal behavior which simplifies the controller tuning. For the outer loop, the set point of the dissolved oxygen concentration is normally ranged from 1.5 to 2 grams per meter cube, and the optimal concentration is at 2. And the control strategy utilizes a linear airflow distribution, and two sensors are implemented in the system system. The first sensor is to detect the dissolved oxygen level, while the second sensor is to detect the airflow rate. By implementing the set point of the dissolved oxygen concentration in aerobic reactor, it enables the plants to operate in a condition where the ratio of the activated sludge process nitrogen removal efficacy to the energy required by the whole plant to be improved. As a result, the system offers a comprehensive view as well as optimal distributes for control strategies. That's all from me. Thank you.
Hello, my name is Lo Jia Cheng and I'm going to present about the challenges and recommendations of the control system. The first challenge is the sensor. Sensors that are faulty could cause noise and poor results. Since the cascade controller is used, the faulty sensor will cause huge error because it could cause a huge energy loss or accidents. Moreover, time delays might happen if the sensor is not correctly placed. Next, the control system has high energy consumption. It is because the electrical energy supplied is lost due to low blower and compressor efficiency. Lastly, a aeration treatment plant would often result in the release of greenhouse gases. The greenhouse gas release such as carbon dioxide, nitrous oxide and methane are actually detrimental to the environment because they would cause global warming. Hence, several recommendations can be made to overcome the challenges. First, the filter can be installed to the sensor to reduce the sensor's noise, and the sensor should be regularly maintained to prevent faulty data from being obtained. Next, the sensor location and the control mechanism such as the changing of the original feedback control mechanisms to the feed-forward control mechanism is quite effective to overcome the time delay for the sensor. Moreover, the energy consumption can be overcome by applying the microprocessor-based control system or fuzzy controller. It is found out that applying this kind of control system could actually reduce the energy loss by 10% from the blower and 50% from the recycling stream. And it's because the most direct method is via improving the air compressor and the blower's efficiency. And lastly, you could apply the rig bed system by effectively reduce the CO2 emission by twice the amount of the conventional one. And next, we could increase the retention time and increase the DO concentration to reduce the nitrous oxide release. And very lastly, we could modify the plant design by trapping the release of the methane gas from the sludge. And the trapped methane gas can be recycled or reused as biogas or other purposes.
In this paper, we have managed to achieve all three objectives of the project, which are to determine an effective control system in the aeration system in order to determine the concentration of dissolved oxygen, to study the important elements in the control system of dissolved oxygen, and to justify the implementation of the control system in terms of environmental and chemical engineering elements, as well as to determine the challenges of the control systems and to suggest recommendations in order to improve the process control. From the literature review, we can conclude that wastewater treatment is indeed an essential component in any industrial process. Hence, it is important to ensure an efficient and environmentally sustainable wastewater control systems in order to minimize its negative impacts towards our environment. Hence, that is all from us. Thank you.